Okay, good morning again. I see that some are still connecting, but maybe it's time to start to not lose too much time to present our new Middle members activities. First, I will give the floor to our President, Miklos Antic, to give you the welcome. Miklos, the floor is yours.
Ladies and gentlemen, good morning, and welcome to this webinar introducing the new member of EGEC. I'm very glad to tell you, and as has been announced, that we have got more than 30 members joining us lately, and then with that we have overpassed the number of 200 members of EGEC, which is quite an achievement. Since EGEC is established more than 25 years, then it shows that the importance of what geothermal industry and geothermal represents to decarbonizing economy, heating and cooling. Well, I welcome you all the new members as well, and I'm very glad to pass the floor to Philippe Dumas to moderate this meeting and introducing all these members who are present today in number of 10 members listed in the agenda today. Thank you very much and have a very nice meeting.
Thank you, Miklos, for your kind welcome introduction. So indeed, me, I will be quite brief in the introduction. It's just to present you 10 members today. We have, as mentioned, we have 200 members now, and 10 are to be presented today. We will start with the Ministry of Environment of Slovak Republic. After we'll have Schlumberger, SLB, Veolia, OMV, the Faculty of Mining and Geology from the University of Zagreb, Green Therma from Denmark, Hansen, Downhole, Funke, Kalyosphere, and Geothermal. You can see that the membership of EGEC is quite diverse. Not surprising to have quite a lot of new members from industry, but you can see also we have some researchers and a ministry. Why a ministry is a member? It's because also we are seeing sometimes as a European platform for exchanging best practices for helping development of geothermal. So good to see the diversity also in the membership. And with that, I start immediately to give a floor to Jaromir for some introduction about the Ministry of Environment of Slovak Republic. Jaromir, the floor is yours.
Yes, can you hear me?
Yes, I confirm.
Okay, then my introduction is really simple and it would be really short. For somebody, it should be boring to be a member of a ministry. I am responsible for geothermal energy, for artificial intelligence, and for projects in general. And I see there are a lot of companies and universities and so on. And I'm a normal clerk. And for me, it could be really good to cooperate. I can say you something about my proposal for my cooperation. There are the case of law. There are a lot of laws about geothermal energy. For instance, in Netherlands is a new mining law, separate rule for geothermal energy. For me, it could be really good to cooperate with somebody. They can help me in that geothermal projects to make shorter. For instance, the environmental impact assessment and such a project. And the second thing could be artificial intelligence. For instance, in geology or geothermal projects, the French project, Velisy, and so on. The two cases, law and artificial intelligence. There is for me necessary such a cooperation. Really short. Thank you. That's all.
So I was muted. Thank you, Jaromir. Short but really precise. Maybe with that we can allow some questions. You need to have some interaction. So do you have any question to Jaromir or comment? Also, you can use the chat and the Q&A. You can also eventually raise your hand and we can give you the floor orally. Not at that. Yes, Sarang, you want to intervene, Sarang? Yes.
Hi, Jaromir. That was quite interesting. So, from the artificial intelligence perspective, is it more towards the subsurface or technical modeling that you're looking at AI, or are there any broader applications that you're looking at?
Okay, we are starting with such a project in Geological Institute. We cooperate with Kaplan Institute of Artificial Intelligence, and we want to use it in a project warning system in Žitný Ostrov area. That's a really important system for groundwater, responsible geology, responsible for groundwater. And we want to use this project, this neuronal net for this warning system. For instance, if the pollution is greater or the groundwater level and so on. But we are starting with this project, and if it's possible, I want to search for such project in Europe. They want to help us to use this artificial intelligence. But I must say, we are starting with this. We are not advanced.
Okay, understood. Thank you.
Okay, thank you, Jerome, for your question. Thanks for a question. I don't see more, so maybe let's move to the second presenters. And if there's other questions, maybe you can use the chat and the Q&A that is online tool to also raise this question and answers. And now I give the floor to Najet to present us Schlumberger Oilfield UK Limited.
Yeah. Okay. Good morning, everyone. Good morning. Thank you, Philippe, and thank you, Miklos, for the invite. So, yeah, I realized that it's actually the name of the entity that is listed, but I think everybody knows it's Schlumberger, and since a couple of years we rebranded and we're called SLB. So historically, SLB, we have been more focusing on the oil and gas industry, providing services to the industry from early subsurface studies to execution of projects, whether it's on the drilling side, the completion, etc. And in 2020, we have started a new division called New Energy, where we focus on 5 areas, one of them being geothermal and geoenergy. So through this division, we look at how we can capitalize on the expertise that we have developed in the oil and gas industry, developing technology specific to oil and gas. Yeah.
Excuse me, Najet. We cannot see your screen.
I'm not able to share actually because I think Philippe is sharing. Okay, let me try again. Is it better now?
Yes, it's perfect. Thank you.
Okay, all right. Sorry about that. So I was saying, as a couple of years ago, we have rebranded, and what we are, and as part of the rebranding, we also launched our New Energy division, where we focus on these 5 distinct areas. So one of them being geothermal and geoenergy, but also we have a division looking at carbon solution, at critical minerals, and what we are developing at the moment is more lithium extraction technologies, stationary energy storage, so batteries basically, and then hydrogen technologies. And specifically on geothermal and geoenergy, if we look at the project cycle, we are actually having several touch points along the value chain. We have acquired a company many years ago called Geothermex, which is normally the company that has been involved with the site screening and doing all the pre-exploration, pre-visibility and feasibility studies. Geothermex celebrated the 50 years of existence last year. And if we look at the geothermal projects around the world that have been executed or studied, Geothermex had touch point in at least 50% of those. So it was a good addition to the SLB portfolio, as they bring very detailed and very advanced knowledge on the subsurface, the economics, and the running of a geothermal project. To that, we complement our expertise from the oil and gas with the drilling, planning and execution of drilling operation. And this is one area where we are also involved. On the power plant, it's not typically a play field for SLB, although there are some projects where we are looking at end-to-end integration, and we have partner in specific projects to do the full project cycle and develop and commission a plant to the operator. And then in terms of operation, same thing, we are capitalizing on our expertise and knowledge, whether it is in production or maintenance, in order to bring these technologies, adapt them, and deploy them in geothermal environment. And one of our sister companies is Celsius, and Celsius has been part actually of EGEC for quite some time, and it's also a nice addition to our portfolio in increasing our knowledge and expertise in the geothermal sector. That's all I wanted to present in the 5 minutes. So if there are any questions,
indeed,
yeah,
I think thank you, Najet. I think there's a question for you. How about a landscape for 30 years later?
Oops, sorry, I'm not sure I understand.
Yes, same for me. Maybe you can precise it, because indeed I don't really get the point, and it's from uncertainty. I don't know from one. If not, do you have other questions to Najet about LCLB? Not here. Maybe from a question from ourselves. So you, from where do you operate and which facilities in Europe is operating in the geothermal business? In which country?
Yes, so in terms of SLB footprint, we have facilities in France, in the Netherlands, in Germany. So myself, I look after the West Europe region. So these are predominantly the countries where I'm located, where I look after the business and where we are located. But we have operation bases in the East as well, in Romania, in Hungary, we have an office in Austria, but we do operate in Austria as well. In Southern Europe, in Spain and Italy, and then more further east, because we consider Turkey as part of Europe in our own organization. We also have operating bases in Turkey where we have quite a few geothermal projects actually there.
Okay, thank you.
Yeah, thank you.
Do we have other questions? Yes, still maybe we will ask the questions online to clarify, because I don't know what you wanted to ask, but okay. Anyway, let's move. Thank you, Najet, again. Let's move now to Veolia and to give the floor for the presentation.
Okay.
Stephane.
Can you see my screen?
Yes, perfect. In full screen mode.
Okay. Hello everyone, my name is Stephane Mainguy and I'm in charge of business development support for the district heating and cooling activity in Veolia Group in Paris. Veolia is a global company that provides solutions for the management of water, waste and energy with more than 200,000 employees around the world. The energy activity represents a little more than a quarter of the group turnover, and the heating and cooling networks contribute for 60%. Veolia is currently the second largest private operator in the district heating sector in Europe and wants to become the leader by 2030. The new Veolia strategic program called Green Up aims to speed up the ecological transformation, scale up the use of existing solutions, and come up with new ones to create a better and more sustainable future. Leveraging its expertise in water, waste, and energy, Veolia intends to decarbonize, depollute, and regenerate resources supported by investment of 2 billion euros in the coming years. Veolia operates almost 700 heating and cooling networks worldwide with a total length of more than 10,000 kilometers and provide heat to the equivalent of 7 million inhabitants. Almost 80% of them are located in Europe and mainly in Poland, where we manage, for instance, the Warsaw district heating network, which is the largest one in the European Union. to decarbonize our district heating network and develop new local carbon-free energy loops. We are relying on different green energy sources, such as waste heat recovery from Veolia activities or industrial processes, and renewable energy, such as biomass, solar thermal energy, and of course, geothermal heat where possible. Our main focus is on geothermal heat, and we plan to collaborate with local partners in Europe to develop projects related to deep geothermal heat. Additionally, we also consider acquiring local specialized companies with proven track records to improve our know-how and capabilities in the shallow geothermal field. Regarding ongoing acquisitions, we are currently in advanced stages of negotiation with several local companies, for instance, in Romania and Spain. Here you can see some example of operations. For geothermal heat pumps, we have several projects ongoing, and you can see 3 examples based on a closed loop system, also used as a borehole thermal energy storages in Romania, Poland, and Spain. And regarding geothermal district heating, Veolia operates a heating network in the city of Blagnac, near Toulouse in France. The geothermal well depth of 1,600 meters was commissioned in 1976 and refurbished 5 years ago. 4 heat pumps raise the temperature up to 70 degrees and reduce the temperature of the geothermal water below 10 degrees to discharge it into the river with a maximum flow of 50 cubic meters. Another project, which is quite innovative, is the new Paris-Saclay urban area, where the objective was to implement a low energy and low carbon scheme based on the building's energy performance, together with local production of renewable energies. This 5th generation of heating and cooling networks in Paris-Saclay relies on the use of geothermal energy, the recovery of heat from the cooling of buildings, and waste heat from data centers. 2 700-meter deep geothermal waste doublets in the Albion aquifer provide renewable heat at 30 degrees. And finally, last year, Veolia Poland signed an agreement with Energy, a Danish company responsible for study, test, drilling, and operation for future geothermal waste for the district heating network of Veolia Poznan. And we expect 100 megawatt thermal capacity within 5 years. The drilling of the pilot should start this year, and the first heat production is expected to begin by the end of 2026. To sum up, Veolia expects to develop geothermal solutions to provide carbon-free, sustainable, reliable, and affordable local heat. Thank you for your attention.
Thank you, Stephane. Indeed, quite interesting portfolio already of geothermal project, and good looking forward. Do you have any questions to Stephane and Veolia? I don't see for the moment. Me have a question. So you mentioned indeed you will work on geothermal pump, geothermal heating. You partner with Energy for the subsurface development in Poland, and you focus on the surface development. Is the model you plan to have everywhere, or you plan different models in the development of your systems?
In fact, geothermal, shallow geothermal heat, we can do it everywhere because it's quite easy to develop this kind of technology around the world. For geothermal, deep geothermal heat, for now, it's mainly in Europe because I mentioned we are the majority of our networks are in Europe, and that's why we expect to develop this kind of technology in this area. Maybe in China in the future, but I'm not sure. It's not in our future plan.
Okay, thank you, Stephane. We have another question for you. Is that indeed in the project you mentioned and geothermal heat pumps, you were referring to quite shallow depths at 100 meters deep. Why? The question is, why do you not use boards at the deeper?
You mentioned Paris-Saclay, no?
Yes, I think it was Paris-Saclay. Yeah.
Paris-Saclay, but in fact, we are the operator. The geothermal waste was drilled by the university, in fact, of Paris-Saclay, and they wanted to develop this district heating on Albion aquifer. It's because it's ambient loop network, and the loop is around 30 degrees, and it's suitable for this kind of temperature.
Thank you. And the last question for you, it's not only for it, I think also for us, it's are we going to have site visits to see a bit the plan? So for information, you mentioned Poznan. We have a conference there in Poznan on the 12th of April. And maybe we can have a possibility. And just to announce that we'll organize again this year the Geothermal District and Heating and Cooling Days. We had the first edition in Aarhus last September, and the next edition will be in Paris early September this year. And maybe we can be an opportunity to visit some of the sites mentioned today. Let's see when organizing the events how we can have also that. Thank you, Stephane. I think we had answered all the questions to you, and thank you for your presentation.
Thank you.
I will now give the floor to OMV.
Yes, hello everyone. I hope you can hear me well.
Yes, I confirm.
Let me share. Please, Philippe, can you tell me? Can you see the slides?
I confirm. Floor is yours.
Okay. So OMV Energy is the traditional exploration and production division of the OMV Group. We are the biggest Austrian oil and gas company. We are an integrated traditional oil and gas company so far. Of course, we are driving the energy transition in Austria. That's the vision that we have. We from OMV, we want to make this energy transition happening. Of course, for some time we will depend still on some other resources to Philippe, can you still see my slides?
I confirm we hear you perfectly and we see your slide.
Okay. Now OMV in the coming years will focus very much on the low carbon business. You can see that from 24 on, we will ramp up the low carbon business, and we will slowly decrease our traditional E&P business with significant investments in traditional oil and gas until 26, and then ramp down the business. But meanwhile, use the cash to ramp up our low carbon business because it is very cash intensive. And as one of the example projects, I would like to show you quickly the DEEP project. It's a collaboration between OMV and Wien Energy, which is the energy provider of all Vienna, running a huge district heating grid. And we have very high ambitions because by 2040, we want to have the complete district heating.
Richard?
Okay.
We lost your voice and we lost also your screen.
I'm sorry. So is the screen back?
Not yet. Perfect. It's back.
Okay, good. And of course, the problem you always have in this district heating grid is that you have very fluctuating green energy components like solar, like wind, and then you need a base load. And that we really hope to provide with deep geothermal projects below Vienna, where we hope that we can really enable this complete carbon neutral free heating of Vienna. But of course, it will take time, it will take money and a lot of energy to do that, and we are willing to provide that. That's already the end of my presentation. Are there any questions?
Thank you, Richard. Let's see if we have questions to you. Me have a question. Is when is planned the drilling in Vienna?
So we hope that we can start end of this year, beginning of next year somehow. You know, it very much depends, especially on the approval and authorities.
Okay. And what could be potentially the size of the capacity of such a system?
The capacity itself, the number I don't have in my head now, but of course it will be sizable. That's one of the advantages of geothermal. Of course, you can drill more, you can advance as it's going on successfully.
Okay, thank you. I see that questions are raised for you. So, what is today the length of a district heating network in Vienna?
I'm really sorry, I don't have the number in my head, but district heating in Vienna is the network was already started several decades ago. I don't have the length, but it is a very well established, fast growing network in Vienna. Because in Vienna you have a lot of old buildings. Vienna is an old city. So the question is, how can you transfer gas heated, very old buildings to green energy? And they don't have floor heating. So you don't have these huge heating surfaces, but you have these small radiators that need quite a high temperature. So we hope that with deep geothermal, we can provide a very significant portion of that heat and energy in the future.
Okay, thank you, Richard, for this clarification. Last question to you, and I can probably interpret it in two ways. The question is that, do you do closed loop installation? In geothermal, we have two kinds of closed loop installation, the shallow one, or typical geothermal pump systems. I don't know if it was the question, maybe you can answer if you plan also to do some at shallow depths, no more geothermal pump system, or it's a replication of a project you're also supporting Garcia with Ever. So I don't know if you have some answers to that. Yeah.
So if you look at the type of reservoir you need, and we try to bring our traditional knowledge from oil and gas into geothermal, and our subsurface people are really strong helping us here. But if you look at the kind of rock you need for the closed loop systems, like ever, you need very hard, competent rock. But what we have below Vienna is a very porous rock that has fractures and that has quite a good porosity. So it's not the best candidate for a closed loop system. I think that's why we will have traditional duplets, especially using the aquifer below Vienna.
Okay. Thank you, Richard. And I see that in the meantime, we had the chance also to have online Amy Radberger from Vienna Energy, and she was mentioning that the total length of the district heating in Vienna is 1,200 kilometers. So we have the answer.
Thank you for supporting.
Alive. Good. Yeah. Thanks, Richard, for your presentation and for the exchange. And now we fly not far from Vienna, but we go more in the south to Zagreb, and we give the floor to University of Zagreb to Tomislav and Daria. The floor is yours.
In regards to everyone. So my name is Tomislav. I'm the professor at the Faculty of Mining Geology and Petroleum Engineering, and with me is my colleague, also Professor Daria Karasalihovi from the same institution.
We see your screen, but not yet in full screen mode. If you can just in the display settings at the top.
Sorry for the delay. So, a Faculty of Mining Geology and Petroleum Engineering is the part of the University of Zagreb. University of Zagreb contains 31 faculties, of which also 3 art academies. We have more than 60,000 students on the whole of University of Zagreb and approximately 6,600 in staff. So our own faculty is... Okay, let's hope this time we will go without problems. So our faculty of petroleum engineering consists of several parts of departments that are dealing with nowadays with geothermal energy. This is Department of Geology and Geological Engineering, and our own Department of Petroleum, Gas Engineering and Energy supply. So it is important to say that in the last decade, we understood the energy transition policy, and we incorporate a large amount of new courses and curriculum towards the geothermal energy and CCUS. So I will forward my presentation in this direction. So as you know, petroleum and gas engineering is on the smaller amount nowadays of our faculty, but geothermal energy, let's say, it's a new bright star. So from the experts, we are doing some scientific research as well in EU projects. Currently, we are handling 2 InterEG projects. One is transforming abandoned wells for geothermal production with association with several partners from Europe and our own agency for hydrocarbon and geothermal energy, as well some shallow geothermal energy through InterEG Central Europe axis, and as well we are doing Horizon projects which deals with CCUS. So these are the several branches that we want to focus in the future, especially as we are a higher education institute and working with future engineers that will get to the industry and look for employment in this new energy transition industry as well. So we are also handling energy production and supply, general petroleum engineering, which is also in distinctive part of geothermal energy. So it's the same technology and techno-economic assessment and so on. As well, if we see what are our degrees, so we are doing also bachelor degrees, master degrees in petroleum engineering and PhD studies. Of course, students can choose geothermal energy as a part of the master program in city of Zagreb. We also have a master program in English for participants from all over the world. Our students are often employed in petroleum industry, but nowadays we are seeing a lot of our students being employed as well in geothermal industry, and especially in Croatia. So when we are talking about future, our faculty has moved towards the 3 distinctive axis in our higher education institution. This is front runner, of course, is the geothermal energy engineering, but CCS and CCUS is often elaborated in Croatia, since we have a lot of fields from oil and gas, and as well aquifers, which are more than capable to inject the CO2. So we have several projects also ongoing on some partner industry to elaborate how to mitigate the CO2. As well as the future, we are towards several courses employed over the last several years about hydrogen storage and capture and usage. And I want to remind you that in the last few years, Croatia has been really very keen to exploit its own geothermal energy sites. Most of these sites came from petroleum exploration works from 17 and 80s, but nowadays they are started to get concessions for the private investors. We also have one power plant operating and working in Velika Ciglana with 10 to 15 megawatts, depending on situation. And of course, we have more than 8 new locations that are currently in the process of drilling or documentation and exploration works that will be producing electricity next to 2 to 3 years. Also, a big chunk of these fields are for centralized heating systems. So all of these sites, we hope that in the next 5 years will be in operation. In that way, we will have a large and very fast transition from petroleum engineering and mining and engineering to geothermal engineering. Of course, our faculty will sustain and produce a new generation of engineers for these sites to be fully exploited. I will now switch over to my colleague for a brief presentation about our petroleum engineering summer school, which is part of our institution.
Thank you. Is it okay? Do you see?
Perfect. Yes, it was yours.
Thank you. I just would like to present our petroleum engineering summer school. It's very important event that it's being held every year in June in Dubrovnik, one of the top sightseeing place in the world. Very nice for academic, very nice academic environment, and we were having workshops there from 1987. We have numerous partners on this project, and every year we have 2 or 3 workshops together with other universities from around the world, and also with other partners, partner companies. We are getting professionals as lecturers for our workshops. This year we have 3 workshops. One will be dedicated to production and reservoir engineering, one to gas market, and the third one from June 17 to 21st. Please put the date in the calendar. We will have geothermal energy exploration and production workshop. We will have distinguished lecturers and professors from university, but also people from professionals from the industry. And also we will have representatives from EGEC, and I would like to invite you all to come to Dubrovnik for summer school this June, and for our members we can have a discount, and we will give you information, and we'll put on EGEC. Also, we are all situated. I just want to say that we are situated in Dubrovnik, and for a week we share ideas about all projects that we are dealing with. We share not only academic knowledge, but also knowledge from the industry. So it is a very important place for networking and for learning, life learning. Education, and also it's a place for a nice tourist place to have a few hours after lecturing for sightseeing, and we also go together to excursions. So it's a very nice event, and I invite you all to join us this June. All participants get diploma, and there is also a possibility of publishing scientific paper if you want to share some of your projects with us. For more information, just let us know. Thank you for your attention, and hope to see you in Dubrovnik.
Thank you.
Thank you, Daria. Indeed, a nice place, a nice event. I was there last year for edition 2023. Do you have some questions to them? I see that Jacek was reporting about the Velika Siglena power plant, which is in operation. Other questions? Not at that side. Maybe just a question, Tomislav and Daria. So as a faculty, you mentioned that you have several activities. Do you have also some research infrastructure that will allow you to participate to a European research innovation funding project?
Yes, the faculty is now ongoing 2 Interreg projects. One is especially interested, as I said, related to transformation of abandoned wells from petroleum industry into geothermal. Croatia has more than 4,000 of wells. More than 1,000 of them are currently in operation. And the lead partner is GFZ. And there are several other countries involved. The aim of the project is to address all of the mature oil and gas fields which has some aquifer with geothermal potential present. So we want to tackle these fields and not let them be completely shut down and liquidated. We want to elaborate on the best prospective fields and to address them as a geothermal one in the next 5 to 10 years, when we think all of them should be abandoned. In Croatia, there are almost 30 exploitation fields now ongoing, and the depths are from 1,500 to all the way to 4 and more kilometers deep gas fields. So the potential exists. We are currently exploiting only geothermal fields, but the majority of potential still lies in bottom type aquifers of oil and gas fields.
Thank you for this clarification. And now let's move to the new member we haven't met, and we fly to Denmark to give the floor to Kim for presenting Green Therma.
Thanks very much. And Green Therma is very excited to join EGEC. So my name is Kim Maver. I'm the Chief Geologist for Green Therma, and we are developing a new closed-loop horizontal geothermal well solution, which is really focused on deep geothermal. We are a very young company, so based in Copenhagen and Denmark, founded last year. We're fully capitalized. And what we want to do is be a geothermal technology and service provider. So not operating any geothermal installations afterwards, but develop them and then pass it over to somebody else. We're a very strong management team of 7 people that all has more than plus 30 years of experience, either in oil and gas industry, drilling, or in utility companies. And really what we are promoting here is a unique patented dual vacuum pipe technology or solution, and I'll come back to that in a minute. And due to the way this is set up, we think what this can offer, and we call it Heat Forever solution, has a global reach. One of the things we have focused on is successful execution of our projects, and we are hopefully getting that by partnership with the SLB and KCI Deutschland for the drilling rigs and the drilling services. So just look at the closed loop horizontal geothermal well solution. There's a lot of different solutions being offered through the years. We have a patent pending solution. So what you see on the left-hand side is a sketch of how this works. So you have an outer pipe where you have the cold water floating down to 2 to 4 kilometers. You have a horizontal section where the water is then heated, and that can be 2 to 7 kilometers. And then at the end, if you can see my cursor, it actually returns to the surface, the heated water. And the point here is that this pipe here, the pipe in pipe here inside, we have a vacuum. So instead of losing maybe 30 or 40% of your heat on the way up, we lose hardly any energy. So that's the way we conserve the energy, and we think that it has some very wide applicability. There's hardly any OpEx on this because all the equipment is on the surface. We need maybe a very small pump to actually secure the circulation, and that's it. We have hardly any geological requirements. Again, this is a closed loop system, so we're just looking at temperature and thermal conductivity of rock. Again, closed loop, there's no fraction of the subsurface, there's no interaction with the drinking water. And in general, we see a very limited footprint on the surface. You just have an outtake on the surface, and that can go directly into a district heating or district cooling network. So if we look at the Heat Forever solution, we see applications in district heating networks, of course, which is very big in Denmark and in big parts of Europe. But we also see an uptake of this in district cooling networks. There's a bigger demand for district cooling in the world than actually for district heating. And we also see a lot of different industrial usages. The performance of a system is between 2 and 4 megawatt per well. And that really depends on the temperature at the depth we're drilling to. It depends on the thermal conductivity of the rock, and then the number of wells we will drill. You can drill just one single well, but we can also do a cluster of 5 to 10 wells. If you look at the operations of the system, this, because the limited geological requirements, can nearly always be installed very close to the end user. The flow rate of the system and the energy output can actually be adjusted according to demand. And if you turn off the system, you then have the rock partly reheating. And you could even imagine you have excess electricity during the summertime, and you can re-inject heated water, reheat the subsurface, and then use that reheating during the wintertime. For the geology, what type of geologies are we looking at? We think this can be used in all geological settings. So sediments, which is probably the first place to go. We are very keen on looking at this for salt. Rock salt, the halite, has a very high thermal conductivity. And because, again, it's a closed loop system, we have no issues with executing a project in halite. And salt is also very easy to drill. And we could even imagine this in basement. If you have hot basement and you have the right new drilling technologies, we believe we can also economically execute wells in that geological setting. And with that was my final slide. So thanks very much. And again, we are very excited to join EGEC.
Thank you, Kim, for your nice presentation. I see that people also like it online. My question for you is quite easy. So what is the next step for you?
The next step for us is hopefully we'll drill our first well somewhere in Denmark, not entirely decided on that, sometime middle to late next year.
Okay.
And that would be down to the 3, 4, 5 kilometers, depending on where we drill and the temperature.
Okay. And any plans for replication?
How do you mean replication?
Of the first project with a second project?
That we don't know where that would be. With that, we will hopefully do that in about 2.5 years' time after we have proven the first well here in Denmark. So we are looking at the first multi-well project as well.
Okay, thank you for this clarification. A question from you is what are your plans regarding also district cooling?
So the thing you could do with district cooling is essentially the same system, but then you have a chiller on the surface, and that can then convert the heated water into cold water, 6-7 degrees. And there are district cooling networks being built in Europe and elsewhere in the world. There's a lot of plans for this in Abu Dhabi, for example.
Indeed, and we see also in Europe, it's a niche market, but it's a fast-growing niche market.
Exactly.
And the demand
and there's lots of places where it's hot.
Yeah. Okay, thank you. And last question is just you explaining chillers, absorption chillers, he was assuming.
Yes, absorption chillers, yes.
It was a good assumption. Thank you, Kim, for the presentation. And let's move to other members and continue with meet the members. And the next one is Hansen Downhole.
Hi, and thanks for inviting me. I'm going to share my screen also. Let me see. I'm going to do that. And then, yeah, do you see my screen now?
Yes, perfect. Floor is yours.
Okay, good. Thank you. Yeah, so as you say, we are a new member, and there's a couple of reasons why we are there. Actually, we want to learn more about geothermal energy. It's something we have followed from time. Actually, our background is really in the oil and gas industry. And we want to see actually where is the knowledge and technology needs. Do we have something maybe we could share or help with and so on? And we can help other companies develop technologies and methods. We've done that for years, actually myself also. And also we are working on some new ideas, and we want to see if that is of interest for this community. Yeah. So we are a small competencies technology company located in Bryne in Norway. That's just south of Stavanger on the west coast there. I established it myself and so on, and my background is really from 1985. I've developed a number of technologies and methods for the oil and the gas industry, actually also wellbore and underwater technologies and so on. So I've been inventing and developing complex wireline tools, downhole sensor systems, electric heating systems for wellbores and so on. Also what some people call intelligent completions technologies, and also wet mateable electric and optical logging systems and so on. And we're also working on bismuth alloys and so on for sealing, using meltable metal and so on. And different type of technologies, including also deep depth, actually electrical wet made couplers and so on. But also I've been doing quite a bit of work on a new idea I came up with some years ago, actually using an umbilical for drilling wells, including actually underwater closed loops and so on. And we have a proven record in innovating and doing technology developments, and have about 65 patents in the industry and so on. We work a lot with external companies also, because being a small companies, you can't do it all yourself. And actually, the experience there is actually find the good people or the companies out there and bring together a package that can change the way we do things and so on. So I got a link there from my profile also, if you want to do that. Look at that one. We have direct access to engineering resources and workshop for testing and so on, at pressure and temperature and so on. We also have a first test wellbore. We're going to do 2 more test wellbores. It's not high temperature, but we can heat them actually using our very powerful electric heating for downhole use, or circulate hot fluids and so on in there. So just a few things actually that we are working on that could be of interest for this community. Is actually we have done some testing on a high temperature downhole pump solutions. That is a pump that can pump 300 degrees Celsius, for instance, and there's no wellbore electrics, and it's easily scalable and so on. So that's an early stage on that one. And also we are working on non-elastomeric high temperature sealing, that is metal sealing, but also using bismuth alloy, which is meltable metal and so on. And also, as I mentioned briefly, actually we are working with the Opak Innovation in Norway, where I've been the R&D manager for 7 years until recently, where I started focusing more on Hansen pumps. We have worked on an umbilical-based drilling method there. And that is actually, instead of using drill pipes, you use an umbilical with hydraulic conduits, fiber optics and powers and everything, and use an electrical system to drill the well bores and so on. We have also done some testing of printing casing while drilling, which was a R&D project we did, and we managed to prove that it is feasible. Yeah. So that is actually my short presentation, just to introduce myself and us, and to see if there's anything of interest from both sides. Yeah.
Thank you, Henning. You did a quite interesting presentation. Pleasure to be in Stavanger last week, and its development in Norway and transfer of technologies is quite important for geothermal. My question is that the pump you mentioned at 300 degrees, at what stage of development you're at, what technology readiness level you are close to market, or still some steps are needed?
Well, we have developed pumps for our oil and gas industry, and one of them is for gas well deboring. That pump there can easily take 300 degrees Celsius and so on. There's no elastomers in it and so on. So it will work. It has a low flow rate or pump rate, but we are now looking into how can we significantly increase the flow rate, which is definitely possible for geothermal wells. Mm-hmm. So actually building a pump for geothermal, it will take some development, but it's not really rocket science, I would call it, from where we are.
Yeah. Mm-hmm. Okay. Good. So indeed, I think we can see it's all quite in Europe that we'll need such a pump. So hope you will find opportunities to test and develop it.
Hope so.
Do you have any question from Henning? I just check the chat. What is the ratio of pump capacity to deep? Is it decreasing?
Well, the pump capacity we can easily scale on this one. So reason also, as I said, actually, I've joined this forum actually to learn more. So I need to learn actually what is the requirements? How many cubic meters or barrels per day do you need to pump and so on? And then we can see how to do that. So if anybody has a need, please contact me and teach me how much you need, and then we can look at it and see how can we do that for you.
Mm-hmm. Yeah, good approach. Thank you, Henning. I see some people use the chat also. What is the maximum temperature for pumps?
It is. We know it's going to be fun at 300. We could perhaps go higher, but 300 is what I would call a safe bet for us. Yeah.
Mm-hmm. Okay, and I think with that it was the last question to you. Thank you, Henning.
Thank you.
Now we move to another equipment. It's a Funke. We have Thierry, I assume. No, for Funke, who will present? Or maybe he's not available now. So we'll come back to him later. So we move now to Kalyosphere. Floor is yours.
Okay, share my screen.
Yes, please.
See it?
Yes, floor is yours.
Okay, thank you, Philippe. So accelerating the development of deep geothermal energy is certainly something we all wish at the EGEC. And that's what motivated us to found Kalyosphere. So who we are and what do we want to do? Kalyosphere is 1 year old, and we aim to become a global developer of deep geothermal energy. Our mission is to target deep geothermal resources to provide green electricity and heat, as well as side products like lithium. Our objective is to build rapidly a portfolio of reliable assets, and we all know that now is the right moment to do it. So here is our preliminary roadmap for project development. So we already have a number of achievements. Others are forthcoming, and still others are in preparation. So first, we were pleased to win in co-contracting with another company a tender for geothermal and lithium exploration. So this project is financed by the French agglomeration of Rouen. Besides, we won 5 permits in 3 zones in Nevada. This was last November, and these permits were our first ones. In addition, we have an agreement with partners on both exploration and exploitation opportunities in Turkey. We are also preparing a partnership for an exploration permit in Germany, and we are in advanced discussions for exploration permits in Central Europe. So for those of you who don't know us, and which is most of you, you may be wondering what our strengths are. And there are many, of course, but 4 are particularly significant. 3 are technical key elements of Kalyosphere to successfully implement our methodologies for securing projects. This is what you see on the right here. 1 is the partnership we have with a family office, Thierry. They believe in us, they support us, and they help us realize our first project developments. About our technical strengths, we benefit from the deep tech R&D results and expertise of the GeoTref research project, which was dedicated to geothermal and fracture reservoirs. We also benefit from our affiliated network of expert companies in geoscience and other fields. I'll tell you more about them after. And we have also a partnership with a software company, Aspentech, on geothermal reservoir modeling using the SquaGoCAD geomodeling solution and the GeoTref software platform, which is attached to it. A cloud computing solution to be complemented by high performance computing is also in preparation. The aim is to be able to share software tools, data, models with our partners. Here's some information about our affiliated network of expert companies. Most of these companies are spin-offs from research laboratories or have partnerships with laboratories. 9 companies have already joined the network. They bring cutting-edge expertise and methodologies in geoscience and other fields. The aim is to work closely together to implement relevant and generally innovative multidisciplinary approaches. For your information, here are the co-founders. So we are 4. We are experienced in complementary areas of expertise, and we know each other for a long, long time. So maybe not the dream team, but we are close. So finally, if we had to sum up Kalyosphere, so remember that Kalyosphere is the developer and that we foster partnerships with other developers as well as technical partnerships. So don't hesitate and contact us to discuss exploration or production opportunities. Thank you.
Thank you, Michel, for his presentation. Indeed, welcome to EGEC and to see a new developer, because it's something we notice in recent years that we are lacking project developers. So good to see new developers in the general business. Do you have any questions to Michel? No, maybe I have a question to you. You mentioned that you had acquired a license in the US, no, and in Europe. If you had to compare the two licensing and permitting process, what would be the key aspects where it's easier to develop a project for geothermal?
That's a good question. So this is not something I mentioned. So we target locations, countries where we can go fast. So that means that we are in France, but for the moment, France is not the priority because it's longer for different reasons. So in the Nevada, in the US, it's quite easy. There are biddings. So you have to apply and you have to select the permit. You can propose permit and there is the bidding process. So we participated to the bidding, and if we win a bid, then you have directly the permit. There's no time to wait for that. So we also selected Germany because in Germany it's go fast. We have a partner which work already on Germany prospects, geothermal prospects in Germany, and we know that in very few months we can have access. And for other countries, so the permits are already existing, and the partnership is with companies that are looking for other partners with high competencies in geoscience. What we propose to do with them, and they like it, and we support part of the cost.
Mm-hmm. Thank you indeed. Regarding the bids on licensing, we have seen in Europe, Croatia have launched one.
Yeah.
In Hungary, not a similar system. It was not an open call, and indeed, also we were in discussion with authorities to see what is the best, because indeed sometimes we have to see the pro and contra of the different systems. It's good to be fast, but also to have the right data availability and accompanying documents with that. Thank you, Michel. I don't see if we have other questions to you, not at that stage. So, no, finally, we can give the floor to Thierry. I see that he is back, and to present Funke. So, Thierry, the floor is yours.
Can you hear me now?
Yes.
Oh, cool. Sorry, I was a technical problem. I could not get back to you, so now it's okay. So I will share my screen. I hope it works this time. Thank you for inviting me. I'm happy to be with you this morning and enriching my knowledge about geothermal from everyone. I would like to introduce you a Funke company. We are designing a heat exchanger, and recently we joined the EGEC international group. So my name is Thierry. I'm in charge of thermal energy water division. dedicated to renewable energy solution, and we are focused on using water and particular geothermal energy. Our aim is to offer to the market the best technical solution for filtration and heat transfer, and while developing the future product to our growing market needs around the world. Let me introduce our company and our group, and open a question if you have some. So the group of EGEC is 2 billion turnover, employed around 12,000 people. We are mainly located in Germany. The global package product that we will be able to offer to the market now is a heat exchanger with plate heat exchanger, is a shell and tube, and the filters for a global package of geothermal needs. The factory we are speaking about for the filters are located close to the French border, and the heat exchanger manufacturer is close to Hanover in Germany. I'm personally located close to Paris. Just to give you an idea about temperature and pressure and where we could use those technology. So the plate heat exchanger is more high performance, but lower temperature, lower pressure is mainly used for district heating or district cooling. The shell and tube will be higher in temperature and the pressure, and it's mainly used in power geothermal system. This is some picture about the manufacture. The plate must be compressed between the frame, and we have to manufacture those products to be resistant to the geothermal fluid. So mainly it's a titanium for the plate and so on. So here is the press where we dump the plate and manufacture the plate heat exchanger. There is an example of manufacture of shell and tube in our factory in Germany. And then it's the filters with a pressure maximum of 100 bar and maximum temperature, would say 200 degrees. We have developed a couple of filters, and one of this one is an automatic filters because it's more efficient and less work on site, and always efficient on site. So Funke has become in 10 years the leader of solution on geothermal application, especially in district heating around Paris. And now I would like to share our knowledge around Europe and develop the geothermal and offers you the best solution in the filters and the heat exchanger as possible. So feel free to contact me, ask me questions, and I will also need to visit some geothermal plant to know more about what you are doing around Europe.
Thank you, Thierry, for your presentation. And indeed, I think what you mentioned, it was also referred to it before. We should organize maybe more site visit now to allow people to connect on real case studies and real facilities. But it's something we have in mind. Indeed, we have done in the past. But let's see how we can organize more of them. Also, as EGEC, feel free to liaise with us if you want to have a contact of another member to liaise with and organize some bilateral discussion. We're also here for that. Do you have any questions to Thierry? You can use the chat, the Q&A. From my side, so you were saying that you look at heating and cooling, electricity also. So what kind of electricity project you are looking for? All kind of systems, or the one of low to medium temperature like in France, Germany, or also more high temperature for Iceland and Turkey?
No. With the Shell tube, we could reach as a better resistant, and we say about 200 degree and 100 bar. So we are able to. In France, we did not really develop this system because it's only few geothermal power plants. But in Europe, of course, in Turkey, in Italy, in Iceland, there is a lot of power geothermal plants. So we will be able to supply for heating and power.
Mm-hmm. Thank you. And there's a question for you. Can your heat exchangers works with different heat transfer fluid? And if so, can you calculate the difference of efficiency?
Yeah, definitely. We're speaking here about geothermal fluids, but we're working for all industry around the world. So we have 1,000 fluids in our unit. We just have to adapt mainly the material that we are using with, but the rest we can calculate. We just have to put some data in our system and we can calculate it easily.
Mm-hmm. Okay. Thank you.
You're welcome. Thank you to you.
Do we have any other question? I think it was the one for you. And with that, time is running, and it's time maybe to give a floor to the last presentation, but not the least member, is for geothermal radar.
Thank you, guys. I am Sarang. I am a co-founder of Geothermal Radar. Is my screen coming through?
Not yet. It's coming. It's coming. Yes, okay. Perfect. Floor is yours.
Cool. So Geothermal Radar essentially started as a platform for bringing together data and modeling capabilities for geothermal energy from different stakeholder perspective for investors, operators, and energy users. The idea is to give easy access, accessibility, and connectivity for different geothermal stakeholders. The challenge being that given the diversity of technologies, application, and energy demand that we see, and all of them are rapidly evolving, from a capital perspective, we thought it was important to have a platform that brings together the feasibility and assessment ability for project backers to understand feasibility, both from technical as well as economic and financial feasibilities across location, different technology applications, and different business models that could be employed. So I have, both me and my partner have a background in energy investments, private equity, and banking. And so we thought of focusing on this problem, which gives birth to Geothermal Radar. The challenge we've seen is across different locations, as well as different stakeholders, there's a disconnect in between what language is used, the data standardization does not exist, and there's no one single place where you can say, okay, hey, what happens if for a given location in a 30-kilometer radius, what all energy demands exist? Heat, power, cooling, commercial, residential. Can we bring all of that information in one place so that project feasibilities can be studied under different conditions, and not just at a high level, but also underpinned with a strong techno-economic and financial modeling capability. So Geothermal Radar aims to solve that problem by bringing together these different capabilities in a singular place. What our idea is creating a platform where you can have analysis of energy demands for different kind of energy needs, whether it be power, district heating, commercial heating, industrial, low-grade industrial application, as well as cooling demand across the board. And also combining that with different subsurface technologies, like whether it's EGS, closed loop, shallow geothermal. We're also working on high enthalpy deep geothermal systems to get investors and financiers easy platform to assess at what scale a project would make sense. Also to other players like energy consumers, may it be councils or communities or corporates, to assess if they can use geothermal within their current industrial application and what the economic payoff would be. So the idea is it served as a SaaS platform, bringing together data. What we offer is also a ability to quickly deploy this solution, not just as one standard SaaS, but ability for large companies to incorporate their proprietary data of subsurface information and run feasibilities on their existing inventory of assets or land banks. The idea being the better the integration and better connectivity of this across different stakeholders, including developers with unique proprietary technology, can then be able to communicate the benefits of their particular approach in a given situation vis-a-vis other competing approaches, and both the customer as well as the developers and end clients can have an easy ability to share this insight, as well as financiers would have a quick way to validate all of this and then build on for ongoing restructuring of financial and business modeling needs. What we have right now on the system is capability to, from a data perspective, we have all of US and parts of Canada. We are working on incorporating European data sets across different jurisdictions. So we are working with data sets in Germany, France, the UK, and also looking to expand into Italy, Turkey, and Greece over the next couple of quarters. These are founders. It's me and Vladimir. We have strong background in building financial and energy data products and platforms. We're looking to partner with interested geothermal companies from different aspects of the value chain to see how we can benefit or provide them with enhanced access to the market. On the supplies or on the financial side, we are also working with investors as well as banks to create analytical products so that they can have easier ability to assess geothermal energy. One of the biggest bottlenecks we feel within expansion of geothermal energy is not so much technical, but the access to capital. A large part of the capital that has been currently or in the past provided or used within geothermal has come from public sources, but to rapidly expand geothermal capability, we think that there is a huge need for private capital, both debt and equity, to come into the space, and providing a framework or a platform like this, which allows users to access and analyze capabilities, would be of a big benefit. So I can also just briefly show you the platform itself. So here's the platform. You can explore energy demands, which is highlighted with the blue dots, each with the details of what kind of company exists within a given radius of the site. We also have gathered subsurface information through oil and gas data or other geological survey data. We have ability to bring in model data for from different universities or different research that has been done. And the platform provides a very easy to use user interface to in real time model feasibility and techno-economic performance of different geothermal projects, including stress testing, sensitivities across different parameters. So you can sensitize to see, okay, how would my electricity production behave as a function or any change in production flow rate, or what would the price of LCOE or IRR, how would that behave versus change in any of the given parameters. So that's a quick run through. Happy to answer any questions.
Thank you, Sarang. Yeah, quite interesting project you're developing. Do we have any question to you? We have a couple of, but I don't know if some others want also to interview. So first, my question is that your product you show us so is available on service is covering all countries in Europe.
So currently we are in the process of releasing the data for Germany, France, and UK. We are working with other European geological surveys to gather their data. We do have some modeled information on temperature to depth ratio, temperature to depth models, very similar to what I've shown here. Let's go back.
Yeah, sure.
So if we go back here, we do have information like this where we have modeled depth for reaching 450 degrees Celsius. So we have similar models that estimate these depths for European countries, and we'll be releasing that in a month or so. But yeah, that covers all of Europe. What we're also looking for is hard exploration data or data from oil and gas where it's available to then validate the modeling information we have.
Thank you for the clarification, Sarang. Any other questions to you? I'll just look at the chat and the Q&A. I don't see any, but for sure, Sarang, you have quite a unique tool, so it will be also good maybe to use other opportunities to further disseminate it to more potential audience.
Absolutely. Yeah, we'd love to. Sorry, go ahead.
No, sure, Flo. No, I give you the floor.
No, I was just saying we are actively looking to engage with European players across different value chain within geothermal, maybe equipment suppliers, drilling companies, or even oil and gas companies that have very unique perspective of different facets within geothermal, whether it's getting insights into refining cost curves or getting a better understanding of subsurface geology. So we're happy to engage with anybody.
Thank you, Sarang. With that, it's nearly 12:30, time to conclude the webinar, except if Kim from Green Therma is still available, because I see that after there's still a pending question for you. Kim, are you still available?
Yes.
Yes, so the question for you from US Ockerman is, so drilling at 5 kilometers TVD into hot rock has not been done in Denmark yet. No. So what cost would you estimate for a well?
I think that's a little bit premature to say. Of course, it'll not be a cheap well, but I can just see that there's a lot of new drilling technology being developed for hard rocks like GA drilling. And I'm not a drilling expert as such, but we do see that this is really an upcoming market for drilling into basement.
Okay,
but the slopes, as I said, is the easiest one absolutely to drill, and then you have the sedimentary rocks after that. So stay tuned.
And for your information, Kim is giving me a good transition because last year we organized in April 2023 a webinar on update and drilling technologies. It was one of the most popular webinars we had because it was more than 200 participants and more than 1,000 views on YouTube. And this year we organize again, so we will send next week some information with call for presenters to present some updates on drilling design, drilling technologies, drilling equipment, and the webinar will be organized around late April. So good to see new developments also in this sector. Thanks all for your presentation. Thanks a lot for your support as a member of EGEC. Indeed, it's a growing sector, and it's good to liaise, to know better each other. We will have other opportunities to meet, also physical meetings. Nice always to network during physical meetings. And with that, I see that Miklos, you're back, and I can give you the words for the conclusion. And from my side, I wish you a good end of the day. Miklos, for yours for the conclusion.
Yeah. Well, ladies and gentlemen, thank you very much for these presentations. It was my great pleasure to follow the activity of new members. Well, some of them I met during other events, and I'm looking forward to meet one day all the EGEC members in one place, as we did last year at the 25 years anniversary, and encourage that you network and learn from each other and boost geothermal ahead. Thank you very much.
Thank you. Have a good day. Bye-bye.
Bye.
Thank you.
Thank you.
Thank you.